All right, we should be live. So welcome to Unit 1 Office Hours number 5. Welcome. Let's see who is joining us today for Office Hours. Week 2 of WorldQuant. So I'm going to put on the agenda. Let's make our way more progress on the IP mini project. Let's try that out. Put that on the agenda. All right, I see Tom is here. Hello, Tom. Subham is here. Hello, Subham. I was thinking, I have a point from the exercise. All right, you can bring that up. Hello, John. The sieve. All right. So you can bring up an individual point for the mini project, but we can also kind of work, I also plan to work that through so I can balance those two things. And Tom, you brought up something about on the agenda, asked something about GitHub. And when you brought that up, were you more interested in GitHub specifically, or were you more interested in Git? I asked because I do plan to talk about Git, and as a consequence, talk about GitHub. All right, let's see who else is here. I see Ermias is here. I see Dendenola is here. Tayo is here. Lyndon is here. Hello, Kenneth. Hello, Paul. Bukola is here. And Thomas saying, I noticed the assertions only have a limited data to test. Leo is here. Arushi is here. Hello, guys. Hope everyone is doing fine today. You have a good weekend. Den is here. Hello. All right. Focus on Git. Thank you. We see Anna is here. Alicia, Salum, Mosam, Omodara. Ankit is here. Siddhartha, hello guys. Hope everyone is doing fine today. Let me know what to throw on the agenda. Someone's asking something about the sieve, so we can put that up there on the board. They can pass the assertions, but have an issue with the final problem. And Tom, are you able to get a score, or what happens exactly when you try to run it through the grader? Let me know so I can kind of figure that out. Let me know what else to throw on the agenda. I got the IP mini project. I got the sieve. All right, one thing that someone brought up last time was Clojure. I think we have time to talk about that and decorators, or perhaps start planting the seed, and we could come back to that later. Okay. All right, and someone's saying, how about the enumerate function? So we can talk about the enumerate function. All right. Let me know anything else to throw on the agenda for today. All right, Tayo's saying he's going to post something up. I can take a look at that just in a bit. Let me know other topics to throw on the agenda. I think I'll first talk about the enumerate, then talk about Clojure and decorator. So that's the initial plan for today. Of course, there'll be more time, but the first two things I will address is the enumerate function and closures and decorators. So I'll go ahead and open up a new notebook. And by the way, post these on the shared drive, and I will point that out. When you go to video downloads, there is a directory called Office Hours Notebooks. I do post these. You guys have access to. All right. Questions 4 and 5, if someone is asking. Hello, Fabi. Okay, so let's go ahead and rename this to Office Hours October 5, 2020. Okay, so let's talk about the enumerate function. So I have a list here, and I have a list of maybe perhaps several characters. And in Python, when you do a for loop or we do an iteration, you iterate through the elements of the container. And I got to sneeze, so hold on while I sneeze offline. Sorry about that. Someone's asking about tuples. I'll throw that in there in tuples. All right, so we could do next, we can say for, I don't know, val in my list, or maybe car if I realize they're all characters. So for car in my list, I can print out car. So notice as I iterate through a container, an iterable, I go through the elements themselves. However, what if I wanted to go through not only the values of the container or the values of the iterable, but I also want to go through their index, iterate through their index, so that when I iterate through my list, I iterate through 0 in A, 1 in B, 2 in C, and D in 3. So what if in my process, I want to make use of the position of that value when I iterate through it? In order for me to do this, I'm going to use the enumerate function. And the enumerate function accepts an iterable. An iterable is just a fancy way of saying anything I can iterate through. For example, my list. And what this do is it will return an iterable of tuples of index value. So it's going to yield me tuples of the index and the value. See, Opiyemi is here, Adidha is here, Abdul Malik is here, Maxim is here. Hello, guys. Alvin is here. Hello. Oratayo is here. Hello, guys. Hope you guys are doing fine today. All right, so the enumerate function will give me an iterable over tuples of the index and value. So we can play around with this. We can say for, I don't know, tup in enumerate my list. Now we're to print that out. I'm going to see the index, the position, what order it is in the iteration, and the value. That's what I see there. So now, given this, I can do some automatic tuple unpacking. In other words, if I have my tuple, I have a tuple of, let's say, 0 and A, I can automatically unpack this tuple by saying index val equals my tuple. This is called tuple unpacking because you can think what we're doing here is, since my tuple refers to two things, contains two items in it, you are assigning the name index to the value of position 0, and you're assigning the name val to whatever is in position 1. So I can print out index and I can print out val. Let me know if there are any questions at the moment. Let me take a look at the chat if anything has posted, anything addition. And we took out what Tayo is saying. A variable is the space and memory of a computer in which a piece of data is stored with an assigned name, serving as the anchor for a specific address of where that data is living in memory. Yeah, you can think of the name, the name as sort of the way we can specify the value contained in that variable. And keep in mind, you can do name reassignment. In other words, you can go ahead and create. I always like to have the agenda in a separate whiteboard. Let's see, online whiteboard. All right, you can say you have a list of A and B here, and you can assign it a name tag. We'll call this my list. We can always retake this name tag and assign it to a new variable. You can say my list equals C and D. So now you've ripped that tag, assigned it to this new object in memory, and this object in memory has no other name. So then Python goes ahead and throws it away. Because without a name, without that anchor as you put it, then it sort of drifts away and we lose it. So now that we saw this, now that we saw enumerate gives us a iterable of tuples of the position and the value, what is typically done is we can unpack it automatically in the for loop. In other words, we can say for I val in enumerate my list, print out I and val. So in short, enumerate function is going to allow us to iterate through not just the value, but the index. Let me know if there are any follow-up questions in enumerate before we move on to the next topic in office hours. And I see a follow-up here, and the question is tuple limited to key value pairs? And the answer is no. A tuple has there's no restrictions about key value pairs in a tuple. You might be thinking of a dictionary. A dictionary stores data in key value pairs. And think about it. A dictionary is a book where there are words and definitions. So a Python dictionary associates data with a key and a value. And a tuple has no restrictions. You don't have to store data in key value pairs in a tuple. It can do whatever you want, basically. A tuple is a heterogeneous collection of ordered objects. It's pretty much like a list. It's going to act pretty much like a list, except for the fact that tuples are immutable. You cannot mutate tuples. So think of a tuple as just like a list, except for the key concept of that tuples are immutable. Yes, so it's just like a list in the sense that you store data by a position. So if I say my tuple and I say A, B, 1, another list, right? Why not another list? And then maybe a dictionary. And the way I access data into the tuple is by its position. So if I want this dictionary stored at the last position, I can say my tuple -1. Yep, thank you. Any other follow-ups? I know there was a question about tuples. I'm addressing them here. Someone brought up on the to put on the agenda. But let me know any questions, any follow-ups regarding tuples. They're just like lists, except for you store data. You don't store. They're just like lists, except for they're immutable. All right, so someone is asking about the function in the algorithms notebook. If you let me know what function specifically, I can take a look at that. Okay, someone is asking explanation for exercise 1 of the IP project. And out of interest of time, what I'll do is I try to avoid re-talking about previous exercises we've gone through, just so we have time for fresher and newer material. So I will advise for that you take a look at Thursday's video. Thursday's video, we talked about the IP mini project. And keep in mind that we have a playlist. We create a playlist for all these videos so you can access them after the fact. And take a look at Thursday's video because we go through that IP, the first question of the IP mini project. So Ella is asking an interesting question. If tuple is immutable, are the elements in the tuple also immutable? And the answer is no. The immutable principle of a tuple only extends in the assignment for assignment. Let's explore that. I have my tuple, and notice that two of those elements are mutable. We have a list and a dictionary. Those things can change. So if I say my tuple and I say position 3, I believe, I think that should return my list. All right, this is my list. What if I append value of -1? So in other words, what I'm trying to do here is I'm trying to mutate something that exists in the tuple. But we said that tuples are immutable. What's going to happen? Well, the immutability principle of the tuple only extends to the assignment. In other words, when I create a tuple, right here. I say A and B and 1, and here's my list, and here comes my dictionary. The tuple will prevent you from switching these objects with another object. In other words, it will not let you switch this list out with a new item. Let's say you want to switch this with a string that says hello. The tuple won't let you do that. The tuple will prevent you from reassigning what object is in the positions of the tuple. It will, however, not prevent you from mutating what's already in place. So a tuple, the immutability principle of the tuple, prevents you from swapping out things in the tuple. Once you've assigned what's in the tuple, it's set. However, it will not allow you to modify, however, it will allow you to modify what's in it. I think the way I like to think about it is, let's say you go on a car trip and it's you and a couple of 4 friends. And you're in this car trip. Once your friends go into the car and you close the door, that's it. You're not going to swap out people on this car trip. Friends aren't going to leave the car, and new friends aren't going to come in. It's set in stone. Whoever is in the car is set in stone. In fact, you're even strict in saying if you sat in the back seat in that specific place right behind the passenger, that's where you are for this whole trip. However, as this trip progresses, you're going to get older. You're going to maybe have cool conversations in the car that's going to change and modify and grow the way you see the world. Maybe you share concepts to each other. So while your position in the car doesn't change, you yourself are changing. You're getting older. Perhaps you're getting wiser. Maybe you're having philosophic conversations in that car. That's the way I think about it. Maybe that's a little bit weird, but let's go back and let's try this out. So if I can append my tuple, and I look at my tuple, I append a value of that list inside the tuple. And now if I look at my tuple, I notice, hey, wait a minute, that list has mutated, which is perfectly fine. In a tuple, the thing that it prevents you from doing is swapping out the objects in its position. Those objects position and what those objects are set in stone, but if they're allowed to mutate, that's perfectly fine. I see Kinjal is here. Hello, Kinjal. All right, someone's stuck in the IP exercise Q2. I do plan to talk about that today in office hours. That is part of the agenda. Go through and talk about Q2 of the IP mini project. So we will answer that today. Okay, so someone brought up the immutability of elements in the tuple. So let's go ahead and now let's see what happens if I try to swap out this list or any of those elements with something new. I'm going to swap it out. I get a type error. Tuple objects does not support item assignment. All right, just a subtlety. Thank you, you brought that up because it gets kind of weird. And maybe my car analogy made sense, maybe it doesn't. But hopefully this clears things up. All right, any questions about tuples before I scratch that out from the agenda? I see a follow-up here. So tuples is fixed size. Correct. So if you create it with 3 elements, that's it. It only can be 3 elements. And only those 3 elements that you created, that you initialized it with. Yes, correct. And Aishi, what you what you summarized there, what you typed in the chat, I completely agree with. Fixed size, it's like you go on a rocket trip, I guess, right? You go out to outer space. People are set in their seats. They shouldn't be swapping around because it's dangerous. No one else can come in. But your life will be changed when you go to space. I don't speak that from experience, but I'm pretty sure that's what happens. All right, let me know any follow-ups regarding tuples before we take a look at something else on the agenda. And I will say, and I will ask you guys, start trying to think of brainstorming of project ideas. One of the things that I want to do for perhaps the last 2 weeks of this course is work on a project together. Maybe nothing too complicated, but set up the scaffolding so that you can take that project. In fact, I will host it on GitHub. So we're going to practice using Git and version control and working with GitHub and make that project your own. So start thinking about, and maybe you don't have too many ideas at the moment, but as you go through the course, you might get more inspiration of what are things we can do for this project. And I think this project will also be great because we'll also learn additional tools and techniques that aren't necessarily part of the core curriculum. So I know someone brought up Git and GitHub, so I would say we'll talk about that in week 6 and 7. So I do ask for your patience, but I do want to do that. So think about maybe some project idea. I have something in mind, but we can talk about it. We can explore different things. Now let's have fun with it. All right. If there are no questions about, there could be some additional ones, but I'm going to scratch out tuples and enumerate. And what I want to talk about here is closure and decorators. It's something we don't talk about specifically in the course curriculum, but it's something that's great to know and understand. Someone is asking, yes, this is Unit 1 office hours. So if you're in Unit 2, yeah, you can stick around if you want. But this is Unit 1 office hours. All right, so let's talk about closure and decorators. And we probably won't go too far into the subject, but I'm going to plant the idea right now, and then we can pick it up on Tuesday. Okay. So let's say I have some, let's do something very simple. I'm going to create a function called, what should I do? What should I call this function? I am going to call this function, let's see, give me a sec. Let's see. How about this? How about maybe I have calculate temperature. I have a function that's going to accept two arguments, a and b. And you think of a and b as some sort of parameters of some sort of physical model, which will tell me what is the temperature of some process. And it's equal to 1 plus 2 times a plus 3 times b. I'll put a little message here saying return temperature based on parameters of model in degrees C. All right, so I see some ideas of projects, so you can go ahead and put them there and I will collect them. Building trading systems, sending signals to cryptocurrencies exchange. Okay. Someone's asking about the major areas to be good at. I can go ahead and answer that just in a bit. All right, so I have a function here that calculates the temperature. Given two parameters, uses some equation, calculates the temperature. So calc temperature, and I can run it for, let's try it out for let's say 1 and 2. All right, that seems to work out. I can change this around, and that works out. Now, you can think of this process here returns temperature in degrees Celsius. But what if we wanted the temperature to come out as degrees Fahrenheit? What if I wanted to return this output in degrees Fahrenheit? Well, one thing I can do is I can define an equation. I can say convert to, I'll call it Celsius to Fahrenheit. Accepts a variable degrees Celsius and it returns the equation, I believe, is you will multiply by 9/5 plus 32 because 0 degrees Celsius is 32 degrees Fahrenheit. And that should work out. So I'll put this there and I pass a value of 100 degrees Celsius, which would be 212 Fahrenheit, and that works out. 0 degrees Celsius should be 32 degrees Fahrenheit. And finally, negative 40 degrees Celsius is negative 40 degrees Fahrenheit. So I have this function here that converts the temperature from degrees Celsius to degrees Fahrenheit. And now, what I can do is I can have a two-step process. I can say degrees Celsius is equal to calc temp of, let's say, 1 and 2. And then what I can do is say degrees Fahrenheit is equal to Celsius to Fahrenheit and pass in degrees Celsius. And I'll print that out just to display the results. All right, let me know if there are any questions right now before we start up this idea of closure. All right, Mohab, I'm not sure how you landed here, but keep in mind that we use alternate times. So right now, tomorrow would be unit 2. So we alternate times. So there's always office hours at the same time, except that the morning time, or what is, like my morning for unit 1, which is Monday, Wednesday, it's the same time, but for Tuesday, Thursday for unit 2. So I think that's what happened. It's one single channel, but it's alternate times, if that makes sense. Abdulmalik, what are the essential tools needed to become a machine learning expert? And those are found in unit 2. So I won't enumerate them right now, but you can think of understanding what is machine learning, supervised, unsupervised, understanding regression, classification, understanding all the different transformation steps that are common to go ahead and take some raw data and use it to create a trained ML model. That's in short how I would answer that, but we have unit 2 where you can gain those skills, so finish up unit 1 so you can take on unit 2. Any questions about this process here? I see Vera is here. Hello, Vera. Nembu. Hello, Nembu. Okay, so let's consider this. We have a function that returns temperature in Celsius, and then we have a second function that we define to convert it to Fahrenheit. And this is a two-step process. So what if I'm able to, this is a two-step process. I don't like this because in my process, I always have to remember to convert this Celsius into Fahrenheit. And I might forget that. So what if I could go back to this function here and I can modify it. I can extend it. For example, what I could do is I can go here and I can say if far for Fahrenheit, then I do the conversion. Maybe I do the temp C. I calculate this value here. And let me just cut that there, paste it there. Call this temperature and say if Fahrenheit, then I can say return Celsius to far and put my temp, else I can return my temperature as is. And I can have to, here I would specify a new argument, called it far Fahrenheit, and I can modify this function here. However, what if I have to do another conversion? What if I want to be able to way to easily convert this temperature to, let's say, Kelvin, a different temperature, a unit of temperature, absolute units? Well, then I would have to say Fahrenheit, or maybe I would say something like, I don't know, units, and then maybe by default it's Kelvin, I don't know, and then specify more and more in the logic here. What about Rankine? So what can get out of hand here is that there are a plethora of other units I can do for the conversion. And I'd have to program this logic into my function. That's going to get tedious. So maybe there's a better way to go about it. So maybe there's a better way. I'll put that. Maybe there's a better way. So instead, I want to make use of decorators. And decorators are functions that modify or decorate the behavior of another function. Hence the name decorator. And the power of decorators is it allows the original function to stay in place, written the same way. All we're going to do is wrap it around an additional function that will modify the behavior of that original function. The way I like to think about it, the way I like to draw it, is that here is our original function. Original function. And we're not going to change the internals of that original function. We're going to leave that original function as is. All we're going to do is define a new function right here that is going to wrap itself around the original function. Here comes the inputs. It might pass those inputs to the original function. The original function returns some outputs, but then it's going to modify that. It's going to do something to it before it returns it out to the world. So it's going to wrap itself around the original function. It's not going to change the internals of the original function. That's going to be left in place because someone else might want to make use of that original function without messing around with the internals. So all I'm going to do is wrap it around so that when someone uses, in my process, when I use the original function, it's going to behave differently because of this wraparound function. Hello, ThadBT and Collade. Welcome. So let's explore that. Let's explore how you would do this. So I want to create a decorator. I'm going to call it calc convert to Fahrenheit. All right, Mohammed, office hours for today for Unit 2 occur at a different time. They occur, I believe, at 20:30 UTC for Unit 2 for Monday and Wednesday. I think it's 12:30. I think it's 20:30. Let me double check that. I believe that's the case. All right, so what this function is going to accept, it's going to accept another function. Keep in mind that functions can be passed around, just like variables. And what this is going to do is I define a function called wrapper. And it's going to accept degrees Celsius. What this wrapper will do, it's going to call upon the function passing degree C, and then it will apply the conversion. It would say return 9/5 times degree C plus 32. So let's explore this. So we define a function here. And in that function, we define a new function. an inner function. And if we examine what this inner function does, it makes use of this function that was passed. It calls that function, assigns it to a result, and then converts, this should be result, and then applies a temperature conversion. And now, what does the outer function return? It returns this function here. So we have a function that defines an inner function, and what that outer function does, it returns the inner function. Okay, it's a little weird, but let's try that out. Convert to Fahrenheit, and it says, hey, give me a function. So pass the calc temp. And I will convert, and I will assign this to a new function. I would say calc, I'll call this calc temp Fahrenheit. All right, so I pass it a function. I can annotate what I do here is I passed a function to convert to far that returns a new function. Let's try it out. Calc temperature far, and I pass it a value of, let's say, 5. Oh, sorry. I have to pass 2 arguments for this calculate temperature, 2 in A and B, so I'll say 2 and 3. I get a type error. So let's examine that. Takes 1 positional argument, 2 were given. If I go back here, it actually accepts only 1. So I got to modify that. Sorry about that. Let's update my wrapper function to accept 2 arguments. We call upon that function with those 2 arguments. Let's modify that. Rerun the cell. Rerun that cell, and let's run this function. And I get a value 57.2. So let's try that out. All right, calc temperature 2 and 3. That is now in Celsius. I can say this deg C and then say deg F equals convert to Fahrenheit. Let's see, convert to Fahrenheit, and let's see, convert, it's called, what do I call it? Celsius to far. Sorry. I get the same answer. So notice, I defined this function, convert to far. And what it basically did is that it gave it a function, we gave it a function, and it returns a new function. That new function there is modifying the behavior of the old function without changing the internals of the old function. Someone is asking, what is the error about the positional arguments pointing to? It is pointing to the wrapper, how I originally defined the wrapper to accept 1 argument, but it should have accepted 2 arguments. I see a question here about the material. Are we allowed to share the videos and notebooks with people who are not taking the course? And the copyright is for your personal use. So hopefully that answers your question. Yes, Kenneth, you are correct. Thank you for answering that. The materials are copyrighted, so it's for only your personal use. So notice this function here is sort of like a factory. It's a factory. What it does, it accepts a function. It returns a modified version of that function. So now you can use that modified version. So we'll leave it that there. Let me know if there's any follow-ups. We'll pick at this. I'm going to go to work on the IP mini project. So what we've done is we defined a decorator. We've defined the decorator, but we'll see a little more example of its usage tomorrow. I want to save that for tomorrow. I want to plant this seed here. All right, so I see a question here about the 23. Is the code block above the 23rd block, is it independent of the decorated function? And yes, it's independent of the decorated function. Yes, it can decorate any function that we pass it, so long as it accepts 2 arguments. We can talk about how we can modify this behavior. We can talk about how we can extend the generality of this decorator that we've created. So the power of it is, let's define a new function. I define a new function, my new function. Def new function accepts 2 arguments, let's say C and D, and it returns C plus D. Very simple. And I can say new func decorated, deco, and I pass it to convert to far, and pass in new func, and I can say new func deco 1 and 2. And let's try that out. 3 degrees Celsius, I do Celsius to far, and I say 3, and I get the same answer. Okay, let me know if there's any follow-ups. I want to come back to this tomorrow, do an extension of what we saw here, but hopefully you're seeing the power of this decorator concept. We can define a generalized function that modifies the behavior of any function that we give it, and now we don't have to modify the internals of that modified function. Decorators make things easy to scale up. Imagine if I had 10 functions that convert temperature, that returns the temperature in degrees Celsius. And imagine if I want to modify each of those 10 functions to do the conversion to Fahrenheit. That's a hard task, right? The more writing of code, the more prone of error. Instead, we define a generalized decorator that does a conversion just in one place, and we can apply that decorator whenever we need it. We'll pick this up tomorrow, as I keep on saying. Let's go ahead and look at the IP mini project. Let's make progress there. Yes, so actually we will see that at symbol. We'll see that at syntax for decorators. We'll go and, if you don't mind, we'll explore that tomorrow. In fact, that's basically a shorthand of what we're doing here. This manual thing, where we pass the function assigned to a new variable, that at there takes care of it for us automatically. Oops, that is my solutions. Okay, so let's examine this IP mini project. All right, did I just close that? Oh, there it is. All right, so we worked on Q1 on Thursday. Let's pick it up on Q2. So we can test if a Mercy number is prime by using this Lucas-Lerner test. First, let's write out a function that generates the sequence used in the test, given that the Mercy number with exponent p, and the sequence can be defined as follows. So in other words, for a given value of p, we can construct a sequence based upon this pattern here. So we start off with an initial value of 4. And depending on the value of p, we apply this equation. We construct the sequence, and then we can check. We do this all the way to p minus 2. So in other words, if I were to take a look at this, what we want to do is, let's say we're going to find this sequence for a p value of, I don't know, let's say 2. A p value of 2. If we look at the equation, we start off with n naught equals 0. So n0 equal to 4. And then we apply the next value of the sequence is the previous value squared minus 2 we divide by 2 to the p minus 1, and the remainder of this division is the next value of the sequence. So we always start off with 4. Let's try out the p-value of 2. So that means the previous value, we'll go with the next value of the sequence is. So it's the previous value squared minus 2 is 14 divided by 2 to the 2 power, 2 squared 4 divided by 3. And if I do my math correctly, this should have a remainder of 2. And we keep on constructing this sequence until we go up to p minus 2. So maybe an exponent value of p wasn't so helpful here, since the sequence ends at 4. So we can choose a different number. Let's choose a p-value of 4. Let's choose a p-value of 4 and construct a sequence. So we start off with 4. We have 4 squared, and that's 16 minus 2 is 14 divided by 14 modulo 2 to the 4th power is 16 divided by 15, which is 0. And then we apply the equation once again. So 0 squared is minus 2. I think things get out of hand here. But nonetheless, we have this equation. We keep on applying to it until we reach the sequence of p minus 2. So in other words, if we have p equals 4, we have sequence 0. Position 0, 1, 2, and that's it. We stop right there. So the first thing we got to do is let's construct a function that will generate this sequence. And what do you think might be a good data structure for this sequence? What are your suggestions? What's a good data structure here to use for this sequence? Half the battle sometimes is deciding what is the appropriate data structure. A list. So I see a list. And for the people who recommend a list, what was your motivation for a list? Why would a list be a good data structure for this sequence? You have an array, so a Python version of the array is a list. So what motivated your decision to choose a list for this data structure? Why is a list a good data structure here? Yeah, so list can be modified. So for this sequence, we are generating new members. So we're generating new members, so we have to perhaps deal with something that's mutable. Yeah, list can be modified. And the other reason I see this post in the chat, it's ordered. A sequence has an order to it, and a list has order. A list is a heterogeneous collection of ordered objects. It's laid out in order, so that when we have that list, and I say, hey, give me the value at sequence 5, what is the 5th sequence, what's the 5th element of the sequence? I can index into the list very easily. Right, it makes it, since a list is an iterable, makes it very easy to iterate through it. Right, so we see two reasons, the two primary reasons to use a list here is mutability, because we'll be growing this sequence, and the way we store the data is by position. And a sequence has an inherent position. So I have the sequence, I say, give me the whatever value is position 3. I can do so very easily using a list. Yes, order. Now I could have used a dictionary. However, that is a bit, it would work out, but it'd be a little too much trouble. Because if I use a dictionary, the keys would be the position of the sequence. So if my keys of this dictionary are really just positions, then maybe I should just use a list. So I could use a dictionary, but it's easier to do it using a list. So with that said, let's write out this equation here. Let's look at it. So we start off with the sequence with this first member of 4. They always start off with 4. That's a definition of this equation, of this sequence here. And then we have to iterate up to p minus 2 inclusive. So every time you find yourself, I want to iterate from this number to that number, think of using the range function. So for I in range of 1 all the way to p minus 2 plus 1. And the reason why I'm doing this here is because the range function gives an interval from start to end, but the end position is exclusive. Let's try that out. Let's prove it to ourselves. So if I say range of 4, that means 0, 1, 2, and 3, but not including 4. And since I want to start with 1, the reason I'm starting with 1 is because I already know what is the value at position 0. It's 4. So I have to do that plus 1. And I find this a little more readable because this is sort of telling me it goes from p minus 2 inclusive. But we could have done the math already. I'll just keep it there. I'll let Python do the math for me. And then the next member of the sequence, I'll call that num, is the sequence before. So now you see why it's easy to work with the list here, because if we look at the equation, we look at the previous value of the sequence. So I minus 1. We square that, and we minus 2. Put that in parentheses right there. I'm going to blow this up. Sorry, I should probably have done this earlier. And we divide by 2 squared p minus 1. We'll look at the remainder. And that becomes the new value of the sequence. So I say sequence append number. And then finally, once this for loop has terminated, well, I want to return that to the user. Return my sequence. Any questions with this function we wrote out? Yeah, so why the plus 1? And the reason is because range does inclusive exclusive. So I want to, if I look at the definition, I want to go all the way to p minus 2 inclusive. So I do want to include the p minus 2. So that's why I throw in that plus 1 there. So p minus 3 would not give the correct result since I'm terminating the sequence early. I need to go to p minus 2 inclusive. So p minus 2, this will go p minus 2 exclusive. So adding plus 1 makes it inclusive. So other questions about this function here? All right, define this function. Now we're ready to use it. Let's try it out. Lucas Lermer result, and let's pass in Lucas Lermer 2. Value 4 is just 1. Let's do 3. 4 and 0. 4, 14, and 14. Okay. Looks like it's all right. Looks like it's working all right. All right, someone say, please explain the num variable. I can go ahead and talk about that. So here, this num is defining what is the next value of the sequence. So basically, num is this n of I. I probably should call it n of I, would probably perhaps be a more readable name. But this is creating the new member of my sequence. And then I'm appending it to this ever-growing sequence. Okay, let's see other things we were bringing up. P minus 3, wouldn't it mean we are terminating at P minus 2? So if we said P minus 3, so p-value 4, and we do P minus 3, if we say range of 1 to P minus 3, we would notice we are terminating early. So if P to 4, we want to go through 0, we're going to go through 1, 2, 3. Sorry, we want to go through 1 and 2. And let's see, for I in range, print out I. Notice nothing happens. So let's do 5. We do 5, do 1, 2, and 3. We only do 1. So we got to make sure it's actually plus 1, not minus 1. So let me change that. And there we go. We go through all the ones we needed to. All right, someone is asking a question I'm trying to wrap my head around wrappers. Good joke. Is it not simpler to make them in 2 separate functions? And it might be simpler initially to have them as 2 separate functions. But now, one thing that's going to happen is, well, what I'm trying to do is cut down the number of code that I'm writing, this 2-step process, where I have to calculate the temperature in Celsius and make sure I convert it to Fahrenheit. And I might forget, as I write my code, that conversion. So what I'm trying to do here is I'm trying to modify the behavior of the original function. So we'll see more examples of it tomorrow with the decorator. But I'll think about maybe a different way to think about it to kind of see, okay, why would it be better as using the decorators? Okay. All right, so is y minus 1, shouldn't it be just I? And the reason why is because if we look at the formula for this sequence, it says we go from 0 all the way to P minus 2, inclusive. So what that means is if P equals 5, just like we have here, we need to go through 1, 2, and 3. All the way to P minus 2, which is 3 in this example, inclusive. So we need to include the third position, 1, 2, and 3. So we would have done just P, then we would have done an extra one. We don't want that. We went all the way to P minus 2. So that's why we do P minus 1 in this example. Okay. Other questions we will have regarding Q2? Okay, sorry. Someone said I'm not talking about P, I'm talking about in the loop. Sorry about that. Let's take a look at that. So why are we doing I minus 1? And the reason why is because if we look at the formula, what it says is the sequence value at position I is the previous one, I minus 1 squared. So let me just double check that I do that correctly. Yeah, I minus 1 squared. And since we have a list, we can easily index what was the previous value, I minus 1. Okay, let's see any follow-ups. Yeah, I can explain the sieve algorithm, and I probably will get that more into later this week. So maybe I can talk about that starting tomorrow, talk about generally what's happening with sieve, and we probably go a little more in depth into it later on this week. I like to go things a bit order. In order helps keep track of our progress, but I do plan to talk about that not yet. All right, but itself it's stating from 1, not 0. So going back to your question, well, we start off with an initial sequence of 4. The initial sequence value is 4. So, but I itself is starting from 1, and the reason why we're starting from 1 is because we already know in all these Lucas-Lerner sequences, they always start with the same initial value of 4. So since they all start with the initial value of 4, we can just skip 0 and just start off the iteration with 1. Someone is asking, what is the significance of the Lerner sequence? Well, it's for testing out for primes. And primes are important because they are used for things like encryption. All right, so we are coming towards the end of our hour, so we'll go ahead and talk more about decorators tomorrow, make more progress on the IP mini project, and talk about the sieve. So I will keep track of this agenda. We will pick it up tomorrow. All right, I'm glad you, Basa, I'm glad you got it, right? Sometimes a little tricky, so glad you got it. All right, guys, take care and have a good rest of your day, and see you tomorrow. Also think about project ideas. Want to gain some skills for the first 6 weeks. For the last 2 weeks, we can focus on a project. All right, it'll be fun. It'll be interactive. We'll learn some new skills.